walk you through PostgreSQL on OCI with Volumez. So who is Volumez? Volumez is the cloud-aware data infrastructure as a service company. And recently we've partnered with Oracle. We're available in the Oracle Cloud Marketplace and part of the Oracle Partner Network. So basically all cloud providers provide block services in a discrete, fully managed service. Right? This is also the case for OCI with their block volumes. This is proprietary as the software-defined storage infrastructure behind the hypervisor black box that you attach to VMs. It provides basic resilience and data services, and often there's challenging price performance, especially for high-performance scenarios. That said, OCI block volumes typically is the default for infrastructure as a service type workloads. So what does Volumez do differently? So the Volumez approach really is a SaaS service where you define the required profile and define a policy that allows you to assign kind of the requirements of the actual workload and then provision storage that is optimized for performance. So what we do is we're a composition layer that uses 100% native Linux data path. Basically, we configure Linux such that the environment becomes highly resilient, and we do replication of data, for example, similar to what OCI block volumes does, but fully configurable. You can say how much bandwidth, what the latency should be, what the IOPS requirements are, etc., to drive 10x price performance over many of the alternatives. How do we do that? You may wonder. Well, every cloud provider, including OCI, typically has storage optimized instances. In OCI, those are called the DenseIO series. And those have local NVMe drives attached that are super fast in IOPS, etc. And because we stay within the compute network and leverage those drives and make them resilient, we can provide much higher performance and much lower latency. So if you look into our performance benchmarking results on a self-managed PostgreSQL database on OCI, you can here see what the results are. So in transactions per second, database transactions, right? Don't mismatch those with IOPS. These are database transactions. We beat all of the native cloud services, like Aurora in AWS and OCI's own PostgreSQL database. We can hit 65,000 transactions per second. In terms of latency, those are latency in the database transactions, we shine as well. It's 3.1 millisecond latency on average in the database transactions. And in cost, we're 50 to 75% less of those managed services. That said, we provide the composition, we deploy the infrastructure, but you are required to self-manage the database, which obviously is a differentiator why those services cost more, but we go beyond in terms of performance and latency, which often also allows you to drive down the actual compute costs and not have to over-provision to reach the required performance, if you can reach the performance at all on the block volume. So in short, right, PostgreSQL and OCI with Volumez delivers extreme high performance and new economics. 3 times transaction per second, a third of latency, and up to 75% cost savings when compared to Amazon Aurora. So let's dive into a demonstration of this capability and of the benchmark results live in a demo. So let me first walk you through the Volumez portal. And here I'm already signed in. And in the Nodes tab under Infrastructure, you see 3 VMs running. An app instance and 2 media instances. If I go to my OCI dashboard in instances, I'll be able to see the same machines. And actually I see 4 here. The Q63P at the end are my demo environment. And here I see 4 machines where these 2 are the media instances and this is the app instance that I see here. So the media instances are the ones of interest to us. And as you can see here, I have 6 drives attached to the 2 instance types, right? The ones with AA at the end are connected to one of the VMs, and WQ at the end are attached to the others. Now let's scroll to the right and see here what the capabilities are of these Samsung drives attached to the DenseIO series. Right? They each can do over 350,000 IOPS read and 305,000 write. And also pretty impressive bandwidth, right? Almost 2 gigabits per second per drive with very low latency that we would want to leverage in this environment. So what I've done under policies is I've defined 2 policies, a perf1 and perf2 policy, which we can edit. Let me edit the perf1, which is meant for the data of Postgres. And here I've defined that I accept 1 media failure. I've defined capacity as performance optimized. We also support capacity optimized, which encrypts, sorry, not encrypts. It compresses the data, dedupes the data, etc. In performance optimized, we don't touch it, saving CPU time, by the way. And here I've defined I need 4 gigabits per second write and 10 gigabits per second read, 250,000 write IOPS and 500,000 read IOPS with low latency. We actually beat this latency significantly. And then under volumes, I've created 2 volumes, one for the data and one for the wall, basically the log of Postgres. And we've associated the policies with that. Actually, we've associated perf2 with it, which is very similar to perf1. And then those volumes are attached to that instance. So if I look into my attachments, I have 2 volumes attached under pgvol and pgvol in this mount point. Now let's switch to the actual instances that I have. And here you're able to see pgbench running. So I'm running pgbench on the client machine, the one that is not visible in the volumes portal. And here I am in the database, and as you can see, there's quite a bit of activity going here in VTOP in terms of CPU usage across the 96 CPU cores that I have here. Similarly, on the media drives where all the writes are happening and the reads are happening, I do see a little bit of overhead going on the CPUs. It's fairly limited. And the workers you're seeing here are basically orchestrated by volumes, right? We do a lot of NVMe over TCP to connect this machine, the database machine, with the media instances. So let me get out of top and show you the mount points. ls/mount/volumes. Right here, you see the 2 mount points that I highlighted earlier. And if I do a df, here you see that I have quite a bit of space available as configured in the volumes portal. Actually, let me show you that too. Here in the volumes portal, I've defined I need 3 terabyte of data for the data volumes and 300 gigabyte for the wall. So this is all running really nicely, I would say. Let's see what the volumes monitoring environment is saying. So here we see the data volume, right? We had 3 terabytes, so 2.2 terabyte is free and 740 gigabyte is used. And here you see we're hitting, well, we're going beyond 100,000 IOPS. read and over 65,000 IOs in write. Again, with very low latency, we're hammering the system and we're under the 500 microseconds, right? 400 microseconds. If you recall the slide I shared earlier, this is what native cloud Postgres services cannot reach at all. Write latency is a bit higher. And this monitoring portal can show you all kind of details, right? Per media, the write IOPS, etc. The queue depths, obviously also fairly relevant. And similarly, the wall, I want to briefly show you that. 300 gigabyte allocated, 8 gigabyte only used. Again, this is the Postgres logging infrastructure. Obviously there we only do writes, which is 3000 IOPS only, at similar write latency as we've seen in read on the data side. So with that, let me switch back to my shell again, and show you actually that we're reaching, or we're close to 65,000 IOPS, 62,000 and something. Still going way beyond what Amazon Aurora, for example, can do at attractive pricing. So with this, I hope you get some clarity around how we've been set up. And let me switch to a slide to explain you better what you've seen. So I just want to reiterate, what have you seen, right? On the left, you see the Volumez SaaS portal that I've shown in the demo. With that SaaS portal, we have provisioned infrastructure in OCI. There's 4 servers here. The pgbench client, where I ran pgbench, where you've seen the results. The PostgreSQL 14 machine, a database instance running on an E5 Flex machine with the Volumez connector installed. That is basically running the Postgres database. And then at the bottom, 3 drives in every E5 Flex machine. Those are all 6 terabyte drives. Combined into a RAID 1 setup, so that we basically stripe the data across in order to make the infrastructure resilient. And as said before, those are running on the dense.io E5 Flex machines that have those ephemeral drives attached. And with that, 65,000 transactions per second on PostgreSQL, running in your own VCN, so in your own network, managed by Volumez. So thank you for listening in. I hope you're open to test out Volumez. You're always welcome to connect with me, dennis.mulder@volumez.com, or go to signup.volumez.com and get a trial experience. Another great way, by the way, is to go to the Volumez cloud, the Oracle Cloud Marketplace with the Volumez offer, and test drive this all for free yourself. Thanks for your attention, and talk soon.